Hello everyone. Look at this another easiest question from Re-NEET 2026 Physics. The question is, in an adiabatic expansion, the temperature of the 1 mole of an ideal monoatomic gas, gamma is given 5 by 3, decreases from 60 Kelvin to 50 Kelvin. So the work done in this process is, the value of R is given. Okay. So let's write down the values first. So it is given 1 mole here, so the value of N is nothing but 1. Value of R is given 8.3, and temperature is decreases 60 Kelvin to 50 Kelvin. So what is the difference? 60 minus 50. So the temperature difference is 10. Ratio is given 5 by 3 gamma. So work done in this process, the formula for work done we have W is equal to nR delta T upon gamma minus 1. So N is 1 multiplied by R is 8.3 multiplied by delta T temperature difference, which is 10, upon gamma is 5 by 3 minus 1. So in the numerator, if you multiply 8.3 into 10, we'll get 83 upon 5 by 3 minus 1. So do the cross multiplication. So 5 minus 3 upon 3, which is nothing but 83 upon 2 upon 5. So that we can write down as 83 upon 2, and denominator of the denominator will go in the numerator. So multiply by, sorry, it is 3. So multiply by 3. So if you multiply 83 into 3, we'll get 249 upon 2. Okay, so no need to solve this. We know that this 249 is an odd number. So if we divide this odd number upon 2, we won't get the answer in an integer. So answer in a decimal. So option number A is wrong. Option number 3 is wrong. So now we have two options in decimal. So if we cancel out 2 ones are 2, so the first digit in the answer is 1. That means our option number 2 is the correct answer. Or if you solve this full, you will get 124.5 joule in the answer. Okay. So the correct answer for this one is 124.5 joule. Thank you.